Hello, I'm Nathan Faith, and I'm the Exelon Nuclear Corporate Security Cybersecurity Manager, and welcome to the ARC Industry Forum for Industrial Cybersecurity today and tomorrow. And hello to all of you out there that are working within the IT and OT environment, especially to those that have a duty to protect systems that are essential to your processes, whether they're critical infrastructure based or simply a computer integrated manufacturing environment making mindless widgets like fidget spinners. Today, I would like to open a dialogue. Even though it may be rhetorical, I'm hopeful that the concepts that I will raise today will spur you as technology practitioners to seek to find answers and deliver them or share your case studies and successes within the community. There are a few main topics I want to discuss. What is happening today, and what are the trends, and what are the gaps? What is impeding our progress, and what can we do to close those gaps? As you see on the slide, I'm going to speak to convergence, saturation, and fatigue, the trust someone in a zero trust era, and resiliency, return on investment, and reasonableness. Of note, within the last few years, we've seen the convergence of these threats that not only impact IT, they have overreaching tentacles into the OT realm, and sometimes with little customization or modification to cross over into industrial computer systems and industrial control system security. Now, IT and OT convergence in industrial control systems really means what impacts IT could be the same tactic, technique, and procedure for OT, and if mutated or modified, an impact to the industrial control systems could occur. And that is my main focus, critical systems, and those digital assets which are required or elected to be protected from cyber compromise. While my talk is going to focus mostly on areas for improvement, I do want to stress that many of the vendors showcased here at the ARC Forum have excellent offerings to assist us in our daily cybersecurity challenges, and it is up to us, the end users, to continually communicate our needs to them. And on the other cybersecurity solution space today, we have many successful products within the anomaly detection and configuration management change identification space, most of which are only as good as their implementation and operational management. These automated tools help cybersecurity operations and analysts identify assets on their network and establish a point-in-time baseline, as well as help us to understand what good looks like and what alerts to expect if something bad might occur. But most solutions are signature-based, or better yet, heuristically enabled, and far too often these alerts generated are very noisy to the analysts. Now, there are a lot of human performance-based issues with using cybersecurity automated solutions and tool sets. Training and proficiency takes a lot of time and personal commitment. And operating experience has shown us that receiving zero or little to no alerts often leads to complacency, with the belief that everything is good. No alerts, no compromise. Or continual false positives that can occur time and time again has the possibility to drive an analyst to possibly ignore or a real indicator of compromise. Or worse yet, these systems are often set and forget, and they are never questioned for operability, or in some cases, very infrequently validated. And there is potential for the cybersecurity incident event monitor isn't receiving or configured to receive the information that would or should trigger an event for response. Without actively testing and validating an automated solution, it could be actually misleading the security team into a false sense of security, or worse, allowing them to actually be missing an indicator that an attacker has penetrated their defenses. We need to close the gap, close the time gap from initial compromise to the point of detection and their excessive timeframes. It seems to me that we didn't learn from the target breach. While their identification and response was 16 days, according to IBM, many organizational trends have upwards of 200 days passing before an attack was identified. And also, as a startling account from a Ponyman survey showed that 38% of organizations said that it took an average of months or even years to respond to a security incident. Let's factor in the SolarWinds scenario. That's recent. Should all software for a vendor be trusted? Should we trust but verify even those that are protecting us? Should we have a fourth party validate our third-party solutions? Is that what we've come to now? And who is authorized to be that authority? Can we take that on our own voluntary initiative to self-certify or require external authorities to attest that certification, or should there be regulations that drive us there? I don't know. I don't know the answer to that. And frankly, I'm a bit afraid that we might be driven there in the future. And that's why one area to watch and to keep tabs on is inside of all of your technologies. I recommend you start following the progress of the initiative known as the Digital Bill of Materials. But let's talk about what we can do on our own, likely with the assistance of an automated solution with active and engaged cybersecurity analysts and operational security personnel. Some of the challenges that we face are often those that we have a soft answer to for when asked. And if you are asked, are you prepared to answer? The concept of zero trust is permeating organizations. This uncertainty, is it just sheer paranoia, or is there significant merit in the denial mentality? I will offer a personal challenge to you today. What is in your wallet? As in, what is in your ecosystem, your digital ecosystem? Do we know all the IoTs that the ID10Ts have placed on our network? What inherent security risks are opening up within our IT and OT environments? These IoTs, the Internet of Things, have become so cheap to buy and simple to integrate with smart systems, such as the assistants from Amazon and Google, etc. The only thing that is not simple or cheap is ensuring the adequate security of these devices. Often, support is discontinued quickly or completely non-existent. Now, best practices have shown and dictate that you should not have these simple general use IT, IoT, and IIoT devices cohabitating on your industrial control or OT process networks. You should evaluate whether or not these devices require direct connectivity, or if you can have a separate network architecture for those different technologies to reside. Can we identify if someone is fingerprinting our devices passively? How can we identify if we have a counterfeit, fraudulent, or suspect device? Can a security vendor differentiate an imposter device from an authorized device? How can we operate safely knowing an adversary has been or is actively within our electronic security perimeter? Can we identify a compromise prior to impacts? And that is our end goal, to prevent cyber physical damage, or even to prevent a latent active failure that could be time and time again, meaning a subtle impact that can lead to long-term damage. What is a valid probabilistic risk analysis method that factors in compromise rather than just failure modes? Now, to achieve that, digital twins are great, and they can be used for cybersecurity. They're excellent for modeling, but how are they used for demonstrating resilience? A reasonable approach for measuring resiliency is needed. We need a process to be able to inject malware and to see the potential consequences and verify resilience. And how can we know that we are resilient now? Based on past configuration, with the potential identification based on new tactics, techniques, or procedures, or indicators of compromise. If an IOC is released today, would your SIEM have identified it yesterday? With the as known potential for anomalies, can you say, yes, we were protected, or yes, we would have known we were compromised? This is a prime example for the benefit of the MITRE ATT&CK framework and postulated attack scenarios. And this always brings me back to a point of reasonableness. What is critical to protect and what is reasonable protection? What is reasonable to evaluate to ensure resiliency? Just because an attacker could compromise the system, is that system really a target truly of value to them? Would they risk being identified through compromise, or is that target worthy of exploitation? For instance, is it a hot point or an endpoint that permits undetected persistence and presence for leveraging escalation of privileges and/or exfiltration? And how can we navigate through fear, uncertainty, and doubt? Just because a vulnerability has been released doesn't mean that we should leap to evaluate and remediate all of our systems. The difficulty of exploit and the attack surface exposure are two factors that are typically overlooked when a researcher releases a proof of concept or an identified weakness in a product. We need to be able to rely on our defense in depth and credit our existing countermeasures. One prime example of an overreaction is the security response to the bad USB from 2014. Are there active USB-enabled exploits? Yes. However, with bad USB, the specific firmware vulnerability that can exist in certain flash media chipsets. This proof of concept has driven industries to use only hardware-based encrypted or hardened firmware-based USB devices for an attack that has yet to surface in the wild. The return on investment for security peace of mind is honorable, however, not yet realized. Can an adversary defeat an air-gapped or deterministically isolated network, one that is based on a one-way gateway or unidirectional transmission only, possibly using a data diode? Can they perform that attack using readily available technology and remote access to exfiltrate or deduce sensitive account credentials? In theory, yes. However, at what cost and with what accuracy? In the best conditions, with endless costs, effort, and time, this mission impossible scenario could occur. But is it reasonable to expect or regulate an industry to protect their assets from low likelihood events of consequence or impact? Lastly, I want to touch on return on investment. Security is an investment, all too often seen as a cost rather than an investment. We need to continue to stress that investing in those expenditures that provide a significant increase in security are towards safety and resilience. And how can we justify reasonable protections? How can we demonstrate resiliency and return on investment? How can we demonstrate we are protected from tomorrow's threat? What and who can be trusted today and in the future? What we can learn from the solar winds and how us as end users assist each other with this same challenge as to not repeat the cycle. All of these challenges I voiced today are those that require human-deduced judgment, which is typically based on the output of technology. Can we leverage a single platform to provide a trustworthy decision? What can the vendor community deliver to solve or at least close some of these gaps? We need to partner with the vendors and national labs and those that can be seen as solution providers. I challenge all of you to foster a culture of cybersecurity, like safety culture and a security culture. We need to capitalize on our end users as another element of our defense in depth. I'd like to take this minute and end this talk with a note of special thank you to our solution providers and government partners for seeking to address these challenges, and to the ARC Forum for bringing us all together. After all, it is you and I that need to work together to secure today into tomorrow. Thank you.